I'm here with Dr. Collier. He's a professor of chemistry at the Oral Roberts University, and he's also a very sharp apologist. We're here to talk about the size of the universe. So, Dr. Collier, why is the universe so big?
That is a good question. A lot of times, a lot of people from a more secular perspective would argue that how can God be concerned about us, the earth, when the universe is so huge with so many thousands, quadrillions of stars, and nowadays they're finding all these exoplanets and stuff. So the argument is, why is this a little yellow star in the middle of nowhere? Matter of fact, they've even given it a name, called it the Copernican principle. Well, recent data is starting to come out. That's just not so.
Yeah. Isn't the universe too big? Is it necessary to be like that? Couldn't it be smaller for us to live here? I mean, is it any necessity in the universe to have its size?
20 years ago, couldn't have answered that question. And now with the data that's coming out now, it's just absolutely mind-blowing in a sense. It's like it's taken a lot of things that you would commonly see where people use it to try to put down the concept of God or humanity or a planet's specialness is being inverted or turned upside down. As it turns out, it appears to be the universe must be as large as it is for it possibility of life, particularly advanced life and civilization, to exist.
Yeah, this is something very new, I think. I mean, you're saying that the universe must be the size it is for a life permitting Earth. Is that what you're saying?
Yeah, it's something that's popped out in the last 10 to 20 years. The data's been, it's a lot of the latest astronomical observations. And I think a lot of it is people's thinking as they've started to look at it. They've gone back and look at some of the data. Because with the Hubble telescope, and they now have some of the big telescopes in Chile, they've got a huge setup down there, and also with Hawaii, and then a couple other, I think there's another one getting going in Africa. We're seeing farther into the universe than we've ever seen before.
What are the arguments? I mean, can you give some arguments for the reason why the universe has to be so big?
Well, one of them is for the Earth to be about 4 billion years old, and this is an astronomer named Hugh Ross really put forth this argument. He says, for human life to develop on Earth, it's like a house being built. You got to have a foundation. And so it takes time to do this. And also that means you've got to be in a particular age of the universe, where the first set of stars were all hydrogen and helium, and you couldn't build. You didn't have any metals, no iron, no magnesium, nothing necessary to put together a modern cell. I mean, you got to have magnesium, you got to have iron, you got to have all these trace transition metals. I'm a chemist, so I love transition metals.
Yeah.
And they just didn't exist in the first generation of stars. And
All right.
so the first stars grew, collapsed, and then a second set, when these stars supernovaed, created the remnants for the next set. And the next set is the one that produced all the heavy metals that we needed. And these second generation stars, of which our sun is one of those. So you have to be one or 2 billion, many billions of years into since when the universe was first created,
All right.
to even have the chemistry necessary for life. We would have a very, very small periodic table with mainly 4 or 5 elements if we weren't here. Well, to be that old, the universe has also got to be expanding for this to happen at an exact rate that's mind-boggling. Tiny bit slow, you get big black holes and nothing. A little bit fast, you just get fine dust.
So only with a universe that old and that big, we would be able to have the chemistry we have that is necessary for life to be formed, to be created.
Yes, absolutely.
It's like bricks that you need to build a house. So
right.
Wow, that's very interesting. There are any other arguments for?
There's one other fascinating argument was put forth by Michael Denton and he got it from some other guys, a gentleman who in the Unity Universe and a couple other books, started puzzling to have advanced civilization, for mankind to be able to do anything, you got to be able to build a campfire. Yeah. All of modern technology, from beating an iron sword, to doing anything, metals or anything, you got to have a fire. A fire is our means of starting modern technology.
Yeah.
Well, you think about it. If you were an ant, could you build a campfire? By the time you got close enough to put a stick of wood into the campfire, you get burned to a crisp. Well, can you make a campfire out of something that's about the size of our campfire to an ant? It wouldn't last half a second. It'd be poof, gone. So ants can't build campfires like we can. Now, what about an elephant? Or say a blue whale? Well, they're so big, they can't. Can you imagine an elephant grabbing tiny twigs to get a fire started? It's like they're too big and cumbersome. And there's this technical term that's called inertia. What they call the inertial, like if you ever come up to something big and heavy and you push on it and it doesn't move, but if it's really light, you can push it really hard. Well, as it turns out, we are just the right size so that we can pick up a piece of wood and put it there and another piece and do one about every minute or two to keep a fire going.
Okay.
Well, here's the interest. This is what blows my mind. This inertial content, they're suggesting, comes from the rest of the universe. Well, what rest of the universe? One astronomer argued 80% of the matter necessary to give us the resistance and the ability to move, the inertial, what we call the inertial content, comes from galaxies that are beyond what we can see with our best telescopes. Matter of fact, 80% of it comes from things that we can't even see, which means if the universe is not as huge as it is, we couldn't build a campfire. And if we couldn't build a campfire, we certainly wouldn't be making little movies and recording this session here.
Wow, that's impressive. Yeah, that's good. And from a theological point of view, it's also, we have to take into consideration that the Bible says that, God tells us that if you want to see his greatness, the greatness of his mercy, he invites us to look at the heavens, right?
He does. And I've seen clips of some very famous astronomers when they ask, well, what do you think when you look at the universe? And they say, one guy made a comment, said, I go out and look and say, it's an incredible universe. And the gentleman who was asking this guy a question was a Christian. And he says, well, do you ever think about God? And he says, well, I try not to, kind of. It's not all scientists are like that, but it's like, I'll never forget, there was a dean 20 years when I was going through grad school, called me in the stairway one day, and he said, Bill, he said, there aren't many atheists left in the physics department. We have to go elsewhere, which says something about what is going on in a lot of the sciences. You may see a lot of famous names out there in the front, but you go behind the scenes to the guys who are doing all the real work, and you get a very, very, very different story. It's like people are almost getting staggered trying to figure out how in the world did this happen by chance. It really is boggling the mind.
Yeah, it's not possible at all, right?
No, in the snowball's chance.
There must be an intelligent mind.
Intelligent agency. Something with a mind, and it's got to be a mind like none other that we've ever thought of before. Yeah. So to me as a Christian, it's very easy to say God. To someone who's not a Christian, they'll talk about mind and things like that. And that's why you see a lot of people get real interested sometimes in Gaia, because in a sense it's out of desperation trying to find an explanation for this, what I call intelligent causation or intelligent agency, which is a nice way of saying somebody with one heck of a mind built this thing.
Yeah, this is what we call God.
Yes, exactly.
All right, thank you so much, Dr. Collier, for your explanation. It's something really, really interesting, and I appreciate your time and your approach, your take on these issues. Thank you so much, and see you next time.